And I remember him fondly for the dinner we had yesterday. And I remember he told me he's a theoretical physicist, and he is now working with blockchain, the technology behind Bitcoin. And he told me that string theory is smaller than blockchain. So we'll have to hear more about this one.
Okay, thank you, Cosimo. Okay, so first of all, let me thank Network Society and especially David Orban for inviting me here. It's really exciting and inspiring to see all those networks that are now rising and growing and extending and spreading and all speaking the same language, similar agendas, ideas that actually make me optimistic about being able to revolutionize the way we live here on the planet. So, great stuff. I changed a little bit my title to adopt the specific congress. So it's about stigmergic network society. So really how I see the paradigm of network society works. And I will talk about my vision of that network society paradigm, a quick observation from nature, and a little bit of history of humankind, and some of the new, this is working? No. Some of the new means to deploy this kind of paradigm, and eventually some examples. So let's start with a vision. So for that, we need to engage with a little bit of imagination. So imagine a world completely governed by networks, self-organizing networks. Imagine Facebook network, but without Facebook Inc. Imagine people renting apartments with no Airbnb in the middle. Imagine ride-sharing applications with no Uber or Lyft. Millions of people insuring each other spontaneously, and maybe millions of people building startups together. So this is the world that I would like to see. So for that, let's take one step backward and look at nature on a phenomenon called stigmergy. Isn't it beautiful? So stigmergy is indirect spontaneous coordination of agents. Or from Wikipedia, it's a mechanism of indirect coordination between agents or actions. The principle is that the trace left in the environment by an action stimulates the performance of a next action by the same or a different agent. In that way, subsequent actions tend to reinforce and build on each other, leading to the spontaneous emergence of coherent, apparently systematic activity. Stigmergy is a form of self-organization. It produces complex, seemingly intelligent structures without need for any planning, control, or even direct communications between the agents. As such, it supports efficient collaboration between extremely simple agents who lack any memory, intelligence, or even individual awareness. Now, so how would we implement that logic to billions of people? Sorry? So we'll get there, yeah. I will also mention that. Oh, it's a tentative question. Theoretical question. So what is stigmergy? Basically, different agents in a network can emit. So it's indirect spontaneous coordination. By indirect, I mean that it is signal-based. There is no direct interaction between agents. There is a signal mediating actions of agents. So agents emit signals, and then their decisions are also biased by the same signals. And the bias is designed to induce synchronicity of actions, to induce cooperation. Now, by design, I mean that nature have designed this for millions of years to induce cooperation. But now when we're going to talk about people, the question is how do we want to design those rules in order to induce cooperation? And no agent has control of anything. But notice one thing, that this stigmergy, as it appears in nature, is unstable to self-aware exploiting agent. So in that sense, it's semi-resilient. So still an agent, if it was self-aware, could basically hack the system for his own profit. So stigmergy in nature works for very, very simple agents who lack self-awareness. So then the question, how do we improve stigmergy paradigm for people? So this, one example in nature of ants, this of course is just an algorithm or simulation that is run on the computer, and in fact, a very known problem of finding the optimal minimal path between 2 points on any topology is known today to be solved algorithmically in the best way by just mimicking the algorithms of ants, which are very simple. And this is just an example of finding the shortest path. This is another frame from a simulation, a real simulation, where you can see that you're starting basically with a random walk of ants and with some extra rules. This is the stigmergy. And you see how eventually the ants converge on the shortest path. And this is just for the expression. So, in fact, stigmergy is the only large-scale coordination known in nature. It fits very well simple algorithmic agents that they are basically fully automated in a way, already in their DNA. And because of that, there is no need for incentive or trust, because simple agents do not try to hack the system. So in that sense, cooperation is the winning strategy, but actually it's almost the winning strategy. You can actually have better, so to say, selfish strategy for more complex agents. As I said, it's unstable to self-aware agents. So how do we apply those ideas to people? So let's discuss a little bit the evolution of human large-scale coordination. So it started with centralized architecture, then it evolved to federated architecture, then to distributed architecture but with local consensus, and finally I would like to tell you more about distributed architecture with global consensus. And you can use these notions you can use for information distribution, or for value distribution, or for governance. It's the same notions. Okay, so rigid coordination you know very well. It's a linear process of information. It can take very rapid decisions, but it can only efficiently work in very static conditions. It's not adaptable to rapid changes in the environment. It's highly vulnerable to rapid changes, and also highly vulnerable to critical mistakes. Like if you have just one agent taking a decision, there is high odds to take the wrong decision. While as if you have millions of nodes taking decision, some of them will take the right decisions. So federated coordination, for example, democracy and the internet, is semi-parallel, but is very sensitive to corruption because a lot of power is aggregated in some nodes. And still, it's not adapting fast enough. In fact, today's democracies cannot anymore adapt to the technological change that take place so rapidly. There is even better architecture. It's the market or P2P coordination. So it's a subjective distribution, which means that it only optimizes according to P2P interaction. So it optimizes locally. Well, the best example is just pure capitalism. So it does optimize locally, but there is no global optimization. There is no global coordination. So in that sense, it drives competition. It leads to twist and eventually severe inequalities. And as you all know, it's not sustainable. And we would like to build a world with stigmergy coordination, where there is a distribution of power, distribution of decision-making, distribution of value, which is intersubjective. And we call that DCO, Decentralized Collaborative Organizations. This is the real network society that I have in mind. And it has the feature of decentralization, scalability, resilience, macro diversity, and micro homogeneity. And most importantly, and that's the big difference from the big difference from stigmergy in nature, it has an incentive for cooperation. And that's the additional piece you need to add for people. You need to have a built-in incentive to cooperate and not to corrupt the system. So with this additional incentive model, cooperation truly becomes the winning strategy. And that's, I think, the world we all want to live at. So what would be the means for that? Okay, so about a decade ago, people invented the distributed hash table, or DHT. The canonical example is BitTorrent, and it's just a distributed architecture for file sharing. It is distributed, but it cannot carry value. So there is no global consensus built into this protocol. So you can distributedly share information, you cannot make transactions on this protocol. So you cannot build economy with this architecture. But that's the first, I would say, block in that stack. And some examples are BitTorrent, IPFS is a new example, and today there is even more advanced ones called Scenario, which also incorporates social network features into it. And then about 6 years ago, some people, unknown people, have invented the blockchain, which is a distributed consensus protocol. Today, the blockchain is much more than that. It's actually a distributed computer. But the important point is that you have a consensus protocol, which means that the whole network can hold the consensus about, objective consensus about a state. So imagine that we all have a computer that we all run together. Each of us can give input to the software, and none of us can corrupt the software. And this will have dramatic effect on the ability to create global coordination, global economy, and stigmergy. However, the blockchain is only based on algorithmically verifiable input. So the only way to interact with the decentralized network is via input, which is algorithmically verifiable, such as the mechanisms that are called proof of work, proof of stake, proof of storage, proof of CPU, and so on. Proof of movement as well. The problem is that most of the centralized interaction you can think of requires also human interaction. For example, let's say that we are now 1,000 people in the room and we want to write a piece of code together. This already takes place in the open source community, right? Linux, for example. The problem is that how do you distribute the value of that co-creation? Or Wikipedia, for example. Today, for Wikipedia, there are well, it's amazing, but still, there are two issues. Firstly, it's based only on voluntary actions. Like people cannot actually work all of their time and make revenues of that or salaries. And secondly, it's not really decentralized. It's based on administrated architecture. What will happen if you have completely decentralized Wikipedia that people can actually participate and get value from? How much more scalable would that be? Or how would it look like if instead of that, you have the same network that builds some open source technology and so on? But the point is that people are interacting with the network by giving value in terms of code, design, or whatnot. And then the question is, how do you distribute the value of that co-creation among collaborators? So you have to rely on input which is not algorithmically verifiable, but can only be assessed by other humans. And that's where it enters the BACKFEED protocol. So it's a distributed consensus protocol based on human input, which basically means that it incorporates peer-to-peer evaluation mechanics, decentralized reputation system, decentralized value distribution system, and last, incentive model for early cooperation. I'm saying early just to emphasize that built into the model, the earlier you are participating in the network, the more value you get, reflecting the higher risk you are taking. Because the largest problem of decentralized network, and actually a general network as well, is creating the critical mass of participants before the network is actually carrying real-world value. So in order to incentivize people for early participation before there is operational value, basically people who participate earlier get more shares in a way in that creation. And that indeed makes collaboration the winning strategy. So in a sense, the BACKFEED protocol is the DNA for decentralized, instead in ANTS, is the DNA for decentralized collaborative organization, or if you want, is the DNA for distributed network society. So that's how the blockchain stack looks like. There is the DHT, the blockchain, the BACKFEED protocol. On top of that, there will be a collaborative platform and eventually a visual browser. Imagine a browser. Today, we are browsing the internet or Wikipedia or anything via links and clicks. But imagine that beyond this database, there exists a graph. So the internet is a graph. Wikipedia is a graph. Every database that we know today is a graph. But why do we browse it through links? Cannot we just browse it through the graph itself? So imagine a visual browser where you can actually travel the network from the graph, seeing the graph, zooming in, zooming out, and so on. So I'm claiming that this will actually be a necessary tool for participation in such a huge, gigantic network. This is under development, yeah. Where? So there are various groups around the world that are doing something similar to that, and we are basically taking that knowledge and code and gradually incorporating that to the decentralized world. But for example, some projects of this kind, one of them is called Rizi, another is called Kumu, another one is called Mapper. So all of those projects came in the same year. I think many people at the same time realized the necessity of that. Yeah, so this will be like the blockchain stack. This can be like Ethereum, Bitcoin, and BACKFEED makes the protocol. There is application layer, and then the platform or the visual browser layer. And it's very analogous to the internet stack that we all know. So in a sense, we are building a new kind of internet. Imagine an internet which is collaboratively built-in collaborative. So built in that internet, nodes on the network cooperate and build things together. So very, very quickly, I won't get into much details, but very quickly, I'll just say that the protocol works in a way that contributors can make any sort of contributions. Then any other node in the network can evaluate, can assess the quality of that contribution. Each voice is basically weighted by the reputation of each node. So each network has a different reputation score and a different token score. The token score is like the financial equity of that network, and the reputation score is kind of like the influential equity of that network. The important point here is that it is built in a way such that those people who are shown to be aligned with the network, their reputation increases. Where those people who are disaligned with the network, their reputation decreases. This means that when you are voting on some other's contribution, you're actually putting your reputation on stake, which basically makes a feedback loop that drives the system into alignment. However, those who are disaligned with the network at any time can just fork it, like you fork a code on GitHub. They can fork the network, fork the reputation score, fork the token score, and make a new network. In that way, in a natural selection evolution, you make network of networks, which basically everything is open source. This is a model for open source technology. So basically, they all share the things that they agree about, and in a sense compete only about the things that they disagree about, and basically probe all the space of possibilities in a systematic way. So it's diversity at the macroscopic level and homogeneity in the microscopic, in-network level. Yeah, let me just skip that, and if I can go back later into more details if people are interested, the way tokens are being distributed, and reputation as well. So what are the tokens good for? So basically, this decentralized collaboration is making something. It could be decentralized insurance, decentralized startup, decentralized energy grid, or whatnot. And then there are those contributors above that have gained tokens in the early days, and they can use them in order to facilitate the new service or product of that network. But there's also many other users that never gain tokens, and they need to gain those tokens in order to use the network, and they could do that in two ways. They can either just purchase the tokens from the contributors directly in the open marketplace, a decentralized marketplace, or they can just purchase them directly from the network, which is kind of a decentralized reserve fund. And then the cash that is going into the reserve fund can be redeemed. I mean, the tokens of the contributors can be redeemed against that fund. So it's basically an autonomous economy, which is designed to have stabilized token, and so on. And that gives the tokens that being distributed in the early days, it gives them real-world value once the project succeeds. So it goes like that. So initially it has no value, and then people believe in the success of that network, and there is demand for the tokens, and then the value is increasing. At some point here, the community start providing some goods or services to the public, and in order to facilitate or to enjoy those goods or services, you need to have those tokens, and then the tokens value is increasing up until it stabilizes on some value. So that's how this economy is designed. Let me almost end with some examples that are actually under development these days. So for example, you can imagine a decentralized ride-sharing network. So it's a gigantic network of peers driving all over the place, where a rider and a driver can be matched in complete peer-to-peer fashion. So you don't need Uber or Lyft to match those. They can actually, the software that is running the matching algorithm is actually sitting on the blockchain. So you don't need any centralized server to match the driver and the rider. And then the transaction is also directly peer-to-peer between the two nodes. Imagine decentralized journalism. We're actually now working with 2 companies to implement that. Like kind of Reddit, but completely decentralized. Anyone can upload content. Anyone can edit, suggest additions of others' content. Yeah. Right. But then that's where kicks in the reputation score. So basically, it means that there are many, many networks. So you can have one database of a huge database of content, but then many, many networks that looks at this database in from different angles with different reputation score. So maybe your content will be highly valuable in one network and less valuable in the other network. So so each of those networks is self-monitoring the quality of the content. Right, right. So basically, if in some network there is a content A that will not be approved or endorsed in that network, that content will just disappear from the view of that network. But if another network actually endorses that content, it will be viewable in that network. So basically, it's a self-monitoring mechanism. In fact, you know, one thing that people ask, how do you monitor spam in such networks? Because, you know, in a centralized, you know, we already have evaluation and ranking system. I mean, Google PageRank is such system, Quora, and we have many others, Amazon. So why don't just using that on a decentralized architecture? That's one question. The second question is how do you monitor spamming, like bad behavior on decentralized architecture? Because it's already so hard on a centralized architecture. The answer is that, and it's related to question, if you just take centralized evaluation systems and put them on decentralized topology, they are miserably failing, basically. And the reason is because you can easily hack the system and spam it. That's the point. So you need to have a completely new notion of evaluation system, completely new notion of reputation, and so on. And that's also the answer for the second question. In fact, the answer is that it's actually easier to control spamming on a decentralized network because you don't have one monitoring authority. Each network has, if it has n nodes, it has n monitoring authorities. So actually, it's much easier to control spamming. Yeah. Yeah. Yeah, I'll finish in 1 or 2 slides. So you can imagine a decentralized insurance network, like billions of people insuring, completely peer-to-peer insuring each other. with this technology that I'm telling you about, there is whatsoever, there is no reason for insurance companies. I mean, once these use cases are deployed, insurance companies will not be able to suggest anything better than that. It will be more fair, it will be more aligned, nodes on this network will be more aligned, it will be cheaper, and it will scale. So a centralized company will just simply won't be able to compete with that. You can imagine decentralized makers, decentralized startups, like what would happen if millions of people actually build a startup together? How would this look like? A decentralized VC. But in one room. A decentralized environmental movement, actually related to the previous talk. We are in touch with several organizations, and I would like to get in touch with the last speaker as well, about making a decentralized, like large-scale decentralized environmental movement, and of course, decentralized social network. So just before I'm finishing, just to tell you that there are many beautiful people that are responsible for this dream to become true, and this is already not updated as new people are entering all the time. But these guys here are, or most of them are fully time dedicated to this project. And let me just end with one last sentence. So basically, I just want to tell you, welcome aboard to the transition that is going to take place for humanity. Be prepared, and most importantly, don't worry, because nothing is under control. Thank you.
Thank you, Matan. And we still have like 2 minutes for questions, like really short question, really short answers, and then we'll have to go forward.
Yeah, first, thank you very much for a great presentation. I have a question regarding the blockchain. How do you look at the blockchain growth versus computing storage, computing power versus availability for truly decentralization?
So this is indeed an excellent question. I mean, scalability is the largest problem or the biggest problem of the blockchain. It's called the scalability problem, and I think that's the only problem left in order to complete that technology. So this is in progress. I can tell you of what the solutions look like. It's not yet completed, but what are the ways people are taking? It's a little bit technical though. But the idea is that you don't need. So the two, I would say, direction is one. You don't need to register everything on the blockchain. So you can register a lot of things on other topologies like the DHT, then just in a way zip them and just register the zip on the blockchain. That's one direction. And the other direction is that the point is that why blockchain is so expensive in terms of computing power. It goes together with the consensus protocol. The consensus protocol works because all the nodes in the network are repeating the same actions. That's what brings the consensus. But on the other hand, it's very expensive because all nodes of the network are doing the same actions, the same computation. So the way to kind of resolve that tension is by having not all nodes of the network observing each and every transaction, okay? But then doing that in a complicated, complex manner so that hackers cannot kind of track the changes of topologies that observe the network and basically attack it. So we have the same, so actually we have dealt with the same problems in the BACKFEED protocol and resolved them in the same way. So this is kind of the direction, but you need to turn those words into algorithms and functions and machine, and that's much more complicated. But very smart people are working on this in these very days.
Unfortunately, we do not have time for any more questions. I'm sure Matan will be available for answering those and chatting about it later on. But thank you, Matan, for that speech, and let's hear it.